Okay, so we have a video here on taking a sampling distribution of a mean. All right, so this is a little bit of a deeper idea in statistics. So what we're going to do is we have some population that we're trying to learn about. And what we do is we take a bunch of samples. Okay, so they're going to be samples of size n. Okay, so n could be like 10, 20, 30, 100, but all the samples that we're going to take are all of the same size. So we got a bunch of samples. Now, if we keep taking samples, what's going to happen is that the mean of these samples, okay, so I've pulled, let's say my sample size is 12, right? So I've pulled 12 values. Pulled 12 values, right? And then what I do is I look at those 12 values and I take the mean of those 12 values. Okay, so now the question is that if I did this over and over and over again, right, what would I expect this mean to be? Well, the mean of these values for any sample of size n is going to be normally distributed. Okay, and ultimately we should expect the mean of all the samples to be the same as the mean of the population. That's not unexpected. So this distribution is what we call a sampling distribution. And this is a sampling distribution for the mean of the samples. Okay, so the mean of all of the samples is going to be distributed like a bell curve, and the center of that is going to be the mean. Now the key here, so we're going to call that the mean of the samples. That's mean x sub r. The question remains is what is the standard deviation of these means? And there's a nice, neat little formula for this. All right, so let's kind of get another page here to get that down. So recall I've taken samples of size n. That can be any number, right? And we're saying that the mean of these samples is normally distributed around the mean of the population, right? And so the mean of the samples is equal to the mean of the population. But now the question is what is the standard deviation of the samples? And this works out nice and neat. Okay, so mean of the samples is mean of the population. The standard deviation of the means of the samples is equal to the standard deviation of the population over the square root of n. So this means the larger my sample size, the smaller my standard deviation from the means, which means that I'm going to get central tendency here. And we'll look at that in a later section. So this is really kind of an abstract idea. So we're going to put this into a very specific example. So we've identified in this course before that the mean length, the average length of a pregnancy is 268 days. And the standard deviation for that is 15 days. Okay, so this is the population of all childbirths. The mean is 268 days, and it is standard deviation of 15. This is a known thing. Okay, so now what it is like, let's say I sample 100 babies. and look at how long were the pregnancies. Okay, and then what I do is I take all of that data and I find the mean of the sample, right? So I find the mean of that sample. Sorry, that's just x bar, right? The mean of the sample is just x bar. Now, the question is what would be an expected range for the mean of these samples, right? Well, these means are distributed normally. That's what we've said before, where the mean of this is going to be the mean of the population, which in our case is 268 days, with a standard deviation of the population, which is 15, divided by the square root of the sample size, which is 100. So that's 15 over 10, or 1.5. Okay, so this is saying that the means of the sample are distributed with a mean of 268, because the means of the sample is this equal to the mean of the population, and the standard deviation of these means is 1.5. So this means that if I took this sample, a usual value for this sample should be between 268 minus 2 times 1.5. Well, that's just 268 minus 3, which is 265, and 268 plus 2 times 1.5, which is 268 plus 3, which is 271. All right, so if I took a sample of 100 babies, a normal sample of 100 babies would have, the usual sample would have a mean between 265 and 271. If that mean was outside of that range, this would be an unusual collection of babies, or there would be something wrong with my assumptions here. So, on average, if I take a sample of 100 babies, I should find that the mean of their pregnancies, not each baby's, but the mean of 100 of them, should be between 265 and 271 as far as the number of days. And we'll get into some of the central tendency arguments as to why that happens. And I know that this is confusing a little bit, but we're going to deal with this for a little while, and we're going to keep going at it until it starts to make a little bit of sense for you. All right, so this is the beginning of a sampling distribution about a mean.